Now this section here, the logarithm function, deals with a function that looks like this. Logarithm functions look like this. Extend this down a little bit. Here's the origin. Here's x, here's y. They look like this. Slow growth. Right, so that's the logarithm function. The exponential function that we looked at in the last section is this inverse and looks like this. So exponential growth is very quick growth. Logarithmic growth is slower growth. Well, problem 1 here says to graph the equation on paper. Now, we're not going to actually graph these. We just want to be able to recognize the graph. Then choose the correct graph. All right, so is it this one, this one, this one, or this one? We'll look at the function that we have here. We have, I'll write it right up here on the top. Let me get rid of that color and go with this so it's easier to see. X equals 4 to the y. Now, I want to get y equals something. Now, here's what I know. The logarithm is the exponent. Okay, knowing this will get us through a lot of problems here. The logarithm is the exponent. So here's what I'm going to say. The logarithm, all right, the logarithm is the exponent. So if I just write what I say, I'll say the logarithm, leave a blank, is the exponent. Well, the exponent is a y. Now, the only other number here that's left is the x. So here's what I'm going to say. The logarithm of x is equal to y. And if I say it, the logarithm is the exponent. All right, the logarithm is the exponent. I'll write the logarithm, I'll leave a blank for a minute. The logarithm is the exponent. The exponent is y. The only other letter up here is variable is x. So here's what we have. Now, what function is this? Well, this is the logarithm function. That's what we were just talking about over here. And the logarithm function has that shape. All right, so I'm looking for a function that has this shape. Now that is, look over here at our choices. It's not a, all right, so it's not this one. It's not this one. That looks more exponential. It's not this one. The only one left. Problem 1 here says to graph the equation on paper. Now, we're not going to do any of that, but we want to just be able to recognize the graph. Choose the correct graph. So is it A, is it this graph, this one, or this one? We'll look at our function here. Our function is, I'll do it top right here, x equals 4 to the y. Now what I want to do is I want to get y equals something. Now here's what I know. The logarithm is the exponent. Right? That's what logarithms are. They're exponents. Logarithms are exponents. So let's keep this one in mind. It'll get us through a lot of problems. Logarithms are exponents. Now when I read this problem, I'm saying the logarithm is the exponent. So I'm going to say the logarithm, I'm going to leave a blank here, is the exponent. Now come up here and look at our problem. The exponent is y. So I'm going to write the logarithm is the exponent. Right? So the logarithm of something is the exponent. The exponent is y. The only other variable is x, and I will put that in here. Now here's my function. I've got y equals log of x, and I know what these things look like. Y equals log of x, these logarithm functions, they have this shape right here. Right? This shape right here, slow growth. So look over at our pictures and our graphs and see which one this might be. Could it be A? Well, it looks possible. What about B? Well, B, this is more exponential, so I think we can exclude that. What about C? Well, C doesn't look like anything like logs or exponentials, so we can exclude that. And this one, D, that looks linear, so the only other choice we have left is A. Problem 2 says, graph this on paper, which we won't, but just choose the correct graph. What is this? It's y equals log base 6 of x. Now, y equals log of x. This is a logarithmic function. We know logarithm functions have this shape right here. So do any of these graphs over here have that shape? Well, A looks like it does. B does not. C does not. and D does not. So I think I'm going to answer A here. Problem 3 asks us to find the logarithm base 6 of 1296. Now this is base 6. My calculator has only 2 logarithms on it. It has the log, which is log base 10, and then right above it has ln, which is the log base e. So I don't have a log base 6. Now your calculator may. If you look at it carefully, some of the newer calculators, you can actually write in the base. But if it doesn't, then what we're going to use is use the change of base formula. All right, so we can change bases, and here's that formula. Formula says, if you want the logarithm to some base of some number n, now that's what we want, all right, we're trying to get b equal to 6. Here's what you do. You take a division, and it's going to be this. The logarithm base a, now I'm going to write this, logarithm base a, and that a is the base you have. Now we have 2 bases. We have a equals 10 or a equals e. We might as well just use 10. But here's what you do. You take the m, the number that you want, m, which in our case is at 1296, and that's going to go in the numerator, and in the denominator you're going to put b. That's the base that you want. Right, the way I remember it is this. I got a top number, a high number, and a low number. I put the high number in the high position, the low number in the low position. So I'm going to write this, that the log base 6 of 1296 is equal to, now I know log base 10, so I'm going to use log base 10. Now, high number, okay, high number in the high position, so that's 1296. Low number, which is 6, in the lower position. Now, on our calculators, here's what I'm going to put in. I'm going to press the log key. I get a parentheses, and then I'm going to put in 1296, close the parentheses, press the divide key off to the right, you know, this key here, the divide key. And then I'm going to press the log key again, and I'm going to get parentheses. I put in a 6, close the parentheses, and I got this. I got the log base 6 of 1296 is equal to, I got 4. All right? Now, here's what that means. So apparently, right now, keep in mind the logarithm is the exponent. Now, the logarithm is the exponent. So the exponent is 4, but exponents go on bases. And the base here, what's down in the base, is 4. So if I write 6, put on that exponent, I should get 1296, and sure enough we do. It checks. Now we're looking for the log base 4 of 16. Now look, you know that logarithms are exponents. All right, so this is going to equal some number. The logarithm base 4 is of 16. That's equal to some number. Now just think about this. We can do it on our calculator, but think of it this way. The logarithm is the exponent. Now, the exponent is x. I'm going to put that on 4. So 4 to the x is equal to 16. So you know this one. 4 to what power is 16? Well, you know 4 squared is 16. So we're going to say x equals 2. So we can say that the log base 4 of 16 is 2. So 5, what is the logarithm base 10 of 1,000? Okay, or 10,000. Let's do 10,000. So here's what I know. The logarithm is the exponent. So I'm looking at an exponent. This is an exponent. And exponents go on bases. The base here is 10, although you can barely read that. All right, so I've got some number, x. I don't know what it is. But when I compute that, I get 10,000. Turns out x is equal to 4. 10 to the 4th is 10,000. All right, so the log base 10 of 10,000, that's equal to 4. Now, you could use the change of base formula, but it's kind of overkill on some of these that we already know. Problem 6 asks us to find the logarithm base 3 of 1 over 81. Now, I know that logarithms are exponents, so I'm going to say that the log base 3 of 1 over 81 is equal to some number x. I don't know what it is yet, but now I know this. The logarithm is the exponent. So the exponent is the x. Exponents go on bases. That's 3. So I know 3 to the x equals 1 over 81. Now, we know this. Maybe you remember this. If you take 3 to the first, you get 3. 3 squared, you get 9. 3 cubed, you get 27. 3 to the fourth is 81. All right, so I'm thinking x is kind of 4, but it's 1 over 81. Now, see what you can do here? What if x is equal to negative 4, right? If you have a negative exponent, we drop the base into the denominator. So if I write 3 to the negative 4, I'll have 1 over 3 to the positive 4, which is 1 over 81. So I'm going to claim now that the logarithm base 3 of 1 over 81 is equal to negative 4. And I got that idea of the negative because I've got a fraction here. Drop that down into the denominator. I'll get that negative exponent. Problem number 7 asks us to find the natural log of 1. Well, here's what we know. The logarithm, any base of 1 is equal to 0. So any base. So this natural log of 1, that's really the log base e of 1. Any base at all, this is equal to 0. Log of 1, any base is 0. Problem 8 asks us for the common log of 1. Now, it doesn't matter what the base is. This happens to be a base 10. The log of any base of 1 is 0. All right, let's take a look at 9. We have the log base 3 of 3 squared. Now, let's just write this out first. It's going to be the log base 3. Now, 3 squared is 9. Now, this is equal to some number, right? It's an exponent. Logarithms are exponents. So I'm looking at an exponent here. So what exponent would I put on 3 to get to 9? All right, well, maybe make it look like this. This is some number. It's an exponent. Call it x. Right now, the logarithm is the exponent. The exponent is this x. It goes on the base 3. So I'm going to write 3 to the x equals 9. So 3 to what power is 9? Well, clearly x is 2. Now look it up here. There's the 2. And you know that logarithms are exponents. Now, when the base and the argument, the number you're taking the logarithm of is called the argument. When these two match, you just get the exponent. So if I had something like this, if I had the log base 6 of 6 to the 5th, these two match, I'm just going to get 5. Now in 10, we've got the log of 10 to the negative 7. But like the last problem we just did, notice this is really log base 10 of 10 to the negative 7. And what we said back then was if the bases match, right, this is the base of the logarithm, this is the base of the exponential, of the power. So the bases match, you just get the exponent. Right, so this is going to equal negative 7. Now we can get this one if we're a little clever about this 2. So what we have is the log base 8. Now, do you know that I'd like to get the base to match. Here's what I know. I just know this, that the cube root of 8 is 2. So 2 is equal to the cube root of 8. But I'm going to write it like this. If it's the cube root, I can write it like this. 8 to the 1/3. Now I've got these two matching, so there is the value right there. So I'm going to say now that the log base 8 of 2 is equal to 1/3. Number 12 says the log base 7 of 1. Well, it doesn't matter what the base is. No matter what the base is, the log of any base of 1 is 0. So any number you put in there for the base, a 7 say, the log is 0. I'm going to use the same idea in number 13. The natural log of e to the 4th. Well, keep in mind, the natural log is really log base e, right? Natural log, this is equivalent to ln. All right, so natural log is just log base e, and then what we have is e to the 4th. All right, now I've got the bases matching, so I just get the exponent. So the natural log of e to the 4th is 4. 14 asks us for the natural log of the square root of e. We'll get rid of that radical. Radicals are fine sometimes, but often when we're trying to manipulate symbols or compute, we don't want that radical, so I'm going to write it like this. Square root is e to the 1/2, right? The square root is the 1/2 power. And now remember, the natural log is really the log, the natural log is what? Yeah, it's the log base e of, and then we have e to the 1/2. And now, right, here's what I'm saying, is that the ln is equivalent to log base e of e. And now I've got these bases matching, so there is the value, that exponent. So I'm going to say that the natural log of the square root of e is equal to 1/2. Can we convert this one to logarithmic form? We've got exponential form, right? It's exponential form. Convert it to logarithm form. So I can do that as long as I remember this. Logarithms are exponents. So I'm going to write this. The logarithm, now leave a space. The logarithm is equals the exponent. The exponent is 2, right? The exponent is 2. So I'm going to say that the logarithm, leave a space, the logarithm is the exponent. The exponent is 2. I'll put the 2 here. But the logarithm, now, logarithms have a base. What's the base here? In this problem, you can see that the base is 10. All right, so I'm going to write a base down here of 10, and the other number we have is 100. Now, does it work? 10 to the second is 100. Okay, so here's the form that I want. This is what I'm looking for here. That's equivalent to 10 squared equals 100. Exponential form, logarithm form. We can convert this to logarithm form because I know that logarithms are exponents. So I'm going to write the logarithm, leave a space, is the exponent, which is 1/2. Now the base here, you can see the base on this exponential is 4, so that's going to go on our base, and the only other number here is the 2. Right? So this says that the logarithm base 4 of 2 is equal to 1/2. And that's what we're looking for. That's what we want to write.